Hello, my name is David, and I'm going to present the result of my master thesis, the SiViFlow Algorithm. The idea of this work came up due to the necessity of having a way to generate realistic rivers, which can be influenced by the player input. Nowadays, rivers in games use mostly static information, which means that they cannot be easily altered in real time, and they cannot react to the player. The flow textures are usually created using an external CAD application. Sometimes an artist might need to be constantly tuning the flow, exporting from the CAD and importing into the game engine, and this process can become cumbersome. This work brings two main contributions. First, a simple and automatic method to generate the river flow given an arbitrary mesh, and second, the generation of realistic and adaptive flow behavior. The algorithm is divided in two main sections. One runs on the CPU, another one on the GPU. The simulation engine is responsible for all the simulation calculations that are performed and which are fed to the GPU on the loop in the river particle processor. The visualization engine reads this information that has been sent from the river particle processor and outputs an appropriate flow representation. The first module is a river surface generator. This module starts by generating or importing a river mesh and iterates through all the mesh vertices, flagging all the shore vertices. After identifying all the shore vertices, the algorithm generates the velocity vectors for each river section of the mesh. This allows us to have all the flow vectors stored at each vertex of the river mesh, so they can be easily accessible in real time, and this means that the flow can also be changed in real time. Another advantage is that it can be linked to the physics engine or layer being used in order to react and adapt to the collision points flagged by the physics engine. Here we can see that after placing a couple of control points, we generate a river mesh and the flow is automatically calculated and generated in real time. We can also see that we instantly get the correct flow behavior for the river all across the domain. It's also possible to use a previously generated mesh or a mesh model by an external application. As long as we have access to the mesh vertices, we can process them and generate a suitable flow. River particles. They are a concept we created to retrieve information from screen space to world space. We start by generating a Poisson distribution of points across the entire screen, and we recast these points to the world in order to retrieve their 3D position. This allows us to send only the visual information at each frame to the GPU. As the particles are created in screen space, in order to retrieve their world position, we raycast from the camera and store the collision point of that ray in the world. After we have all the required data, we pack that information into two textures called the flow texture and the auxiliary texture. We store in the flow texture the flow vectors in the green, blue, and alpha channel, and we use the red channel as a global identifier for each particle in order to use it as an indirection and an identifier for the second texture, the auxiliary texture, where we store extra information that might be needed. Here we can see how that works. For each pixel, we retrieve the particle that covers it the most, and we store it in the flow texture. The identifier of this particle allows to address the correct position in the auxiliary texture when we're inside the shader. Our method allows us to adapt the flow in real time according to the requirements of the game. We can change the speeds and tune it in real time. The same can be said for the direction of the flow. Here we can see that we can invert the flow direction for the whole domain instantaneously. In fact, we can make any changes we want to the flow information as long as we have access to the river mesh. Here we show how a possible flow of a coastline behaves. We can make the flow go around objects, or just make it behave as we want it to. The visualization engine is the material we apply to the river. It generates all the flow outputs that we see on screen. It uses a tile-based flow generation method and is extensible with any amount of special effects. Here we can see the river divided in tiles. For each entry, we generate our new normal vector based on the blending of 4 flow vectors that are rotated and displaced for each tile in order to hide repetition artifacts. We can see here how the changes in value of the amount of tiles used in the river surface changes the appearance of the flow. The more tiles we use, the smaller the waves on the surface. After outputting the normal generated by the tile-based approach, we can introduce a wide range of special effects to the visualization engine, such as caustics, God rays, or refraction. It's also very easy to change the color of the water, as it's just a matter of changing the pixel color that is outputted. Other effects, such as reflections, can also be implemented without having to change anything else in the algorithm. This was the explanation of the SiViFlow algorithm. Thank you for watching this video. If you have any questions, just contact me by my email or Twitter, and you can check more info about this project at www.davidbmcine.com.